OK, so unfortunately, due to a minor technical problem, I'm going to be doing more slides and less code. But if you want to see the demo, come see me after. The code does run on my laptop. You're just not going to be able to see it on the big screen. I would like to start this talk with my favorite screenshot of the past year. This is Flight Simulator, which recently kind of got an update, I think a year ago or so. And it's like super high fidelity graphics. You can actually fly around the world. And when the game just came out, you could fly to Melbourne in a suburban area, and you would see this thing. This was, of course, kind of popular, so a lot of people actually flew up quite close. And like you can see this like giant, overarching tower with the epic shadow. And people were wondering what developer did this, how did this happen? So turns out this video game used a data set called OpenStreetMaps. And OpenStreetMaps is one of these data sets where volunteers can put in their own data. And there was a user called Nathan Wright 120 who accidentally wrote a bit of a typo. That house was by accident 212 stories tall instead of 2. But it did lead to this kind of interesting, funny moment. It's kind of like a data quality issue. And this was like one of those things where you could kind of go, kind of interesting, data quality is important because otherwise we get this stuff. This was meant as a joke, and now I want to talk about the thing I actually want to talk about, which is bulk labeling techniques. And what I'm going to be doing, not live, unfortunately, is just show some open source libraries and stuff that I've been working on. But the main problem that I am going to be talking about here is that let's say you want to do a classifier. You want to classify something, people swearing online or whatever thing it is. Whenever you do that, you usually start out with a situation where you've got some sort of large unlabeled bucket of data. And you would really like to get to the other end where you've got some sort of trained model that's at least somewhat reliable. And this is like the cold start problem when you're starting with a model, you could say. You don't always start with a data set that's properly labeled. So what can we do here? Well, one thing you at least should do is make sure that this doesn't happen. This is the Udacity self-driving car data set. And everything in red is a missing label. So this is a data set meant to train your own self-driving car. And you can see that the kid on the bike hasn't been labeled. There's a Ferrari that's not been labeled. There's a woman with a stroller. I'm sure there's also a DAF truck. But this will be bad, right? Whenever you're going to train a machine learning model, you don't want to end up with a data set that has these sorts of issues. Like this is the thing you got to prevent before you actually get to your model. And you might think, well, this doesn't happen all the time, does it? So there is this big data set called SciFar 100. It's kind of like one of these big benchmark data sets that people like to compare their algorithms on. If you were doing like computer vision 10 years ago, this was kind of like one of the big ones. Turns out they have a train set and a test set that's official, and there are duplicates between them. And not just items that are very similar or near duplicates. According to this paper, there are exact duplicates between them. And I should stress, this is a benchmarking data set. This is something that you need to demonstrate against if you want to claim that you're state-of-the-art. Also, it turns out that SciFar, together with a whole bunch of data sets, also come with improper labels. If you look to the photo to the upper right, those two blue jackets, that's not a motorcycle, I think. But that is how it appears in the data set. And this matters, right? Like if I think about this whole step that I want to go from data and then eventually to my model, I mean, I am in this awkward situation where, yeah, I can take my data, I can pre-process it, I can model it, and then I can make some metrics that help convince me that the predictions are going to be good. But if the input data is bad, your predictions are going to be bad. But if you mess up the data, your metrics might still very well be shiny. This is kind of the optimal on paper, broken in reality problem. If you have duplicates, yeah, your accuracy numbers are going to be great. But it doesn't mean that your predictions are going to be reliable. And this is also why I keep telling people that maybe accuracy isn't enough. We need more to convince ourselves than these metrics if we want to do this right. And if I'm honest, this is actually pretty darn scary. Like if we want our field to maybe survive an AI winner, we got to get this sort of stuff right, I think. So if you're going to fix this, yeah, we can do more robust models, that's possible. And yeah, there are pre-processing techniques that are interesting. But maybe we should tackle the problem in the beginning of the pipeline, because otherwise all the issues are just going to propagate forward. That's kind of my attitude and kind of my thesis. But if you're going to tackle the data problem, we should also maybe admit there's one thing that we shouldn't do. And that's what I like to call the mechanical Turk effect, which seems to me like it's still a very popular thing to do. You just say, hey, I've got unlabeled data. I would like to have some labels. Hey, internet, here's a bucket. Please label it. And if you want to read a good blog post on what can go wrong, there is a blog post from my employer. It's called Supervised Learning is Great. It's data collection that's broken. It's from 2017, so the blog has been out there for a while. And the blog basically describes that if you have a labeling task and you send that to possibly the other side of the planet, to a team of people who doesn't share the same problem that you do, and you underpay them, and you give them a boring annotation interface, then maybe you shouldn't expect very great data sets to start with, and then we also shouldn't be surprised that we have pedestrians missing from self-driving car data sets. So hopefully that argument on its own is compelling enough that maybe we shouldn't trust, like, hey, crowd, let's label this together and assume everything will be great. If you really want to tackle this data quality problem, I think the only thing you need to do is just annotate it yourself. That way you're confronted with your own label quality. And also the thing is, you can do this with a team that actually cares. Eventually you are probably going to have a model that's hopefully going to solve a problem. And I don't think a random person on the internet is going to care as much about the solution as you and the team that is trying to fix it. And moreover, as you're labeling, you're probably also learning about your problem. This is also another reason why you shouldn't just throw it out on the internet, because you're probably going to have to iterate on your approach as well. So, we are going to be annotating, and I can imagine that if you've never done it before, you might be interested in some tips. If you really have never done it before and just want to get started, there's a very lovely plugin for Jupyter called Pigeon. Jupyter-Pigeon, pip installable. Code hasn't been changed for 5 years because it just works. It's just a couple of IPython widgets where you're able to give it a list of things that Jupyter Notebook can render, and you just get a couple of buttons, so you can just do classification inside of your notebook. And if you're just trying to get started, this is great. A couple of downsides. I mean, like, the moment you close down your laptop, all the labels in memory are gone, so that's a downside. You also don't get keyboard shortcuts, but again, like, this is free and you can just go ahead and use it. This is, I think, a very solid option. If you're serious, and I should admit, take a grain of salt here, I work for the company that makes this tool called Prodigy, but there are these labeling products that you can also definitely go ahead and consider. Some of the things that I like about this is that the labels actually go to a proper database. There are lots of great labeling interfaces, not just classification. You can also just do substring detection, images, audio, all that good stuff. And it also comes with a Python API, which means that you can do whatever fancy active learning trick you like. But no matter which of these two labeling tools you have, you still have an interesting issue. And that is that there's maybe still a step between that large unlabeled data set and the annotation tool that you're about to use. And this is especially true when you're just getting started. Because for all intents and purposes, this might be like a data set with like fraudulent examples, let's say. And maybe we have millions of examples, and only a few of them are actually going to be interesting for the model. So maybe we don't want to go through every single example by hand. And for that, part of my job is to come up with the sum trick part of this diagram. There are some tricks that you can do where you don't really need much or even any labeled data, but you can still work in such a way that you can learn a lot yourself from labeling, but also in such a way that the model can learn relatively quickly. And the problem definition that I am going to follow is this is when you're just starting out. So all the tricks that I'm about to show you are really good for starting out. I don't want to suggest that they are amazing when you're already 2 months working on a problem. But if you're really just starting out, there's actually a couple of really nice hacks that you can do. And I would like to present a couple of them, albeit just in slides because the live demo won't work. But I hope that people are understanding and excited about this problem, that we might be able to do some good with this. So you just got a big data set. Let's say it's text. Well then, let's then say that we have newspaper articles, just as a sort of tangible example. And I want to have all the newspaper, I want to have a classifier that says, is this newspaper article about sports, let's say. Well then, I can take all of my text, and I can index that in a search engine, no problem, because I don't need labels for that. The only thing that this is going to do is it's just going to make sure that if I come up with a word, it can just very quickly give me all the examples that contain that one word. And if you're looking for a library to do this, Lunar is a great library in Python. It's nice and minimal, single function. You can store the index as a JSON file. It's not necessarily super fast or state-of-the-art, but for a lot of hacking yourself, it's surprisingly great, just because it's a nice little demo tool. Once you have that, you can just say, well, can I come up with sports articles? And you can kind of go, well, tennis and football, and I can come up with a couple of sports titles. And surely if I just throw in a couple of good terms, championship, let's say, then whatever things I get back from the search engine, there's a good probability that it will be about sports. And if you think about like a lot of these text examples, you can usually come up with a couple of words that describe the class very well. Now note, this is not going to be perfect. You are also going to get some examples that aren't about this class, but you are going to get lots of examples, and hopefully, let's say, at least 80% of them are going to be of interest, right? That's a pragmatic way of going about it. There's a downside of this, though, if you think about it. So let's say I actually build a classifier this way, right? So all the sport names that I have. Then I'm probably going to train a model that at some point also just overfits on those few terms. Like it's really going to overfit on the term football and the term tennis. And maybe it will have a little bit of trouble recognizing that there are also sports teams. And maybe just the presence of a sports team might also indicate that it's about sports. So I'm actually interested in maybe doing something like this, but in a way that I'm not just constrained with a token, something I can kind of do a thesaurus kind of a thing. That'd be kind of cool. And this is where embedding tricks come into play. And it's pretty neat if we're lucky. I'm definitely going to do some hand-waving here and glancing over lots of details, but the whole idea is that let's say someone trains a big model out there. They take all of Wikipedia, they take a sentence up to a certain word, and they try to predict the next word, let's say. You can have a big pre-trained network, and maybe the model learns something that's general that you can go ahead and reuse, because words might be used in similar ways. There are also models out there these days that train on more than just one task. If I remember correctly, the universal sentence encoder from Google uses a couple of sentiment data sets and a couple of newspaper article data sets, and they really just try to have lots of tasks in there. But also here you might end up with a system that can kind of learn a little bit from the text going in and blend that with the label going out. And if the text going in is to some degree similar to the text that you have, and if the labels that they've been trained on are also somehow relevant to what you're doing, then maybe that final layer in that neural network has some potentially useful representation that we can go ahead and use. Now, I do want to emphasize we have to get a little bit lucky here because, let's say we have a model that's trained on Wikipedia. If your text is very much unlike Wikipedia, you might still get a bad time. But one thing that is pretty cool these days is that these pre-trained networks are just abundant. Just go to Hugging Face, and there's like thousands of them that you could go ahead and download. And some of them are also pretty domain-specific. You also have models that are for the biomedical domain, for example. But then, given such a model, here's the trick that we can do. We have that one little potentially useful representation. And basically that means that when an example goes in, we have some sort of array representation for it. So for text A, we have an array of numbers A, let's say. And we can sort of make this mapping. So if I have text A goes to vector A, and then for all of that, I can kind of do this thing where I say, what if text A is a sentence like business, stock market, and the economy? Which is not necessarily a newspaper article that you would see, but we do have like words and maybe some associations that we'd like to see in our training data. And you can also maybe imagine that if I take the similarity of those two vectors, let's say from vector A to B and from vector A to C, and let's say that vector B is very similar to vector A, then maybe the text of vector B is also very similar to A. And that means that I might be able to do selection that way. Instead of doing like a proper index where I use words and I have to find exact matches, maybe this can be a nice little approximation as well. And there's actually kind of a nice little trick that you could do with this. Because what you could do is you could just say, let's come up with like a sentence that sort of just should summarize the category that I'm interested in, like the class. Then whenever a new point kind of comes in, you can say, well, we have one sentence that's literally about world news, international politics. The other sentence is sports news, Olympics and football. I mean, the distance between those two sort of class representation vectors and the new vector coming in, you can build a classifier based on that. Just use scikit-learn kneighbors classifier. So I hope that people are like kind of excited about this. You know, this is kind of a cool little trick that you might be able to do. But even though that these embeddings are pretty powerful, I do find myself in this situation where I really want to iterate quickly, and I'm not necessarily interested in learning a new framework whenever a new embedding comes out. So it's great that we have JAX, Keras, TensorFlow, and PyTorch, but if I want to try out the latest and greatest, I really want to learn a new framework just to give the new embedding a spin. So I had originally a demo, which unfortunately I cannot show you, but what I can do is just go to the GitHub page and just show you the framework that I'm talking about. I wrote a package called embetter, which is just a very pragmatic way to give you image embeddings and text embeddings for scikit-learn, just as a single scikit-learn pipeline component. And I do need a tech guy to come back downstairs in a bit because I don't know what the shortcut is to full screen, but in a bit. So the live coding segment right now is going to be me typing in a URL. But the library is called embetter. There we go. And we can sort of zoom in, right? There we go. So the way it works, you just pip install embetter, that's it. And what you can just go ahead and do is you can say from embetter, there's just a couple of components. There is a column grabber, which allows you to just grab a single column from pandas. And then we have sentence encoders and sense-to-vec encoders for text. So typically, just like with the count vectorizer, you would first grab the column such that you have like a list of texts. And then you can just pass that into one of these two models, and then you've got your vectors. I have a similar thing for computer vision as well. I do have an image loader that can load an image from a path. That's then a Python image object. You have a list of that. You pass that along to the PyTorch image encoder, and there you go. We also support most of the computer vision models this way as well. So just as a toy example, which you can find online, what you can typically do is you can make like your embedding pipeline where you grab a column, you embed it, and then afterwards you just have a logistic regression. You can feed that to a data frame, scikit-learn, fit predict, but boom, this is a very quick way, like almost a one-liner, to start playing around with embeddings. That's kind of what this package is doing. And we also have an image API that's a little bit more elaborate. Again, that's because first I have to take the path, and then I need to turn it into a Python image object. But then after that, that's going into the PyTorch model, and also then you've got your vectors. The installing is the part that takes long, because some of these models are pretty big. But this has been out for a couple of months. And this is also something that you can go ahead and play around with. If you're interested in making like a zero-shot classifier, basically what you do is you just come up with a data set like this, with like positive sentiment, negative sentiment, and like a label for each. You can replace this with logistic regression, or you can just put a k-nearest neighbor thing in there, but there you go. That's the pipeline that you can go ahead and use. And then you can tune the confidence such that you only get examples of the class that you're interested in. That's basically the premise. That's basically how this works. There are still some features that I'm going to be building for this. Primarily, right now, there's no GPU support just yet, but I have had people that said, hey, I want to use this on Google Colab, so that's something I will work on probably sometime next year. But this is a pip install away. You can already go ahead and use this. What's the shortcut? Control L. Sweet, thanks. So this wasn't the demo I was planning on showing you, but hopefully that little thing on the side there kind of paints a picture on how you can go ahead and use this. But if I'm very honest, like one thing, maybe I should mention that, because that was in the notebook that I do want to mention. I have this one data set where I benchmark this, and then I ask the question, let's just come up with 4 sentences, use the embedding trick for like a few shot classifier with the k-nearest neighbor, and then throw it against a test set. How much do I get right? And I think I got like a 74% accuracy on like the 4 news classes. Then I figured, hey, what happens if I just train a normal logistic regression bag of words model, and how much labeled examples do I need in order to get the same performance? Turns out it was about 500 examples. And there's kind of two interesting lessons here I do want to mention. Like, on one hand, you can say, hey, it's pretty cool that we might not need to label that much data to get a model that's still reasonably accurate. And that's definitely like the thing I was going for. But at the same time, I also hope you realize 500 examples isn't like a huge amount either. Like, you can also just label that yourself, and it's also still a very valid way to go about this. The bulk labeling tricks that I'm mentioning here are primarily useful when you have like a very imbalanced classification problem, where it's very hard to find that one class that you are going to be super interested in. So do remember, what I'm presenting here is just a trick. You are still allowed to just manually annotate data, and that is still a really good thing to do. That said, there was a downside of this approach that I just showed you. Because one thing that I don't like about it is you do have to come up with like a very good sentence that summarizes this one class that you have. And it kind of becomes a problem of, well, we kind of have to do prompt engineering, which is kind of a hack. And then another thing I was kind of missing is that maybe we can also just be a little bit more visually oriented. So there's also this other package that I made, which is right now one of my favorite tricks. And the package is called bulk. You can pip install it. And it's meant to be used with embetter, and here's how it works. Bulk assumes that you have a data set, like this tweets.csv file, and you have some sort of way of embedding that. Then I also assume that you've got access to a dimensionality reduction technique. In most cases, UMAP will be the thing you want. You can use principal component analysis, PCA, but the downside of PCA is that it's really good at keeping like the global structure intact. But it also means that the clusters have to be global in order to remain intact in your 2D representation. UMAP, on the other hand, is much, I would almost say, worse at keeping the global thing intact, but it's pretty good at keeping the local thing intact. So clusters of things that are close together in like a local space stay together in a two-dimensional representation. But that means that I have a way to go from text to two-dimensional coordinates that are maybe clustered. And that's going to be kind of interesting, because then what I can do is I can say, take all of my tweets and give me the two-dimensional representation, and then I have this user interface where you're able to make this selection on like a cluster of points, and then you get this user interface where you can just sort of see, well, if I make a selection over here, oh, it seems to be maybe about a certain topic. And if you can confirm that it indeed is about a specific topic, one that you would like to pass on to Pigeon or Prodigy, then you can just save these examples in a CSV file. And this is like purposefully minimal. Like, it really just has one button. That's the only thing you're supposed to do with it. It's meant for bulk labeling. But this has proven to be a trick that actually works quite well. And because Embetter doesn't just support text, but also images, bulk can also support images. So if you have a computer vision use case, you can also go ahead and use it. And this has gotten some attention, like people really like this idea, which is kind of cool. But we can go a step further, and oh, it's such a bummer I can't show you this live. So you're going to have to come to my laptop after to see the live demo of what I'm about to show you. But maybe the technique behind it is more important, so I'll try to focus in on that. Okay, let's consider once more how embeddings are typically made, right? And I'll take the image example here. Image goes in, convolutional layers, and at some point we have a dense layer near the end. So not the layer with all the classifications, like the layer before, basically. Because that's the layer that might be very appropriate for embeddings, right? Some part of the image is embedded in it, some part of the label as well. What I could do now is I could say, how about I just annotate 20 examples? And in the demo that I had, which you can also find online, by the way, I had pictures of cats and dogs of different breeds, and I wanted to build a classifier for just cats and dogs. So what I did is I just labeled 20 images for cats and 20 images for dogs. And then I extended this. What I did was I said, well, let's build a new task head at the end. And the idea is where the orange line was the embedding vector before, I'm adding a new dense layer at the end and then a final output layer. And instead of using that orange line, I am now going to be using like the second to last layer there. And why is that? Well, the idea is that, let's say I'm using exception, that pre-trained model. I can keep that frozen. Like somehow that model is already capturing information about the image that I'm interested in, because maybe shapes of ears get detected. I don't know. But some stuff gets detected that might be interesting. But what is going to be interesting to my use case? Well, that really depends on my label. So what I kind of want to do is blend that embedding with the label that I'm interested in. And the way you can do that is you just freeze the exception network, add this one little task head, which is 4 lines of code in Keras, and then only update the weights of that final task head. If you do this, the 2D UMap space goes from looking like that to looking like that. And if you squint your eyes a bit, the UMap chart on the right might have global structure. Because it turns out if you do this for like a binary classification case, in this case, right? If I recall correctly, the top right, those were all cats. The bottom left, those were all dogs. And there's kind of a line in between there that you can almost interpret as if it's like the certainty for belonging to a certain class. And that's kind of nice, because that means that the examples where the neural network is kind of uncertain about is right there in the middle. And in the live demo, which I can't show you, the images that are in the middle, those are like cats and Pomeranians with the same shape of ear. Because somehow it cannot use that feature anymore to make a distinguishing case. And again, this is maybe 20 or 40, I forget, but not like this was done in 2 minutes of labeling. But by doing so, I kind of have embedding-based active learning with a human in the loop. And that's a pretty neat trick. Because you can do this, if you're able to label just a few examples, you might be able to get an embedding space that will help you discover a bit. Because another nice aspect of doing it this way is that this also helps with topic discovery. You can literally hover over a cluster that you see and just ask the question, what's in here? Maybe you'll learn something interesting, and maybe you'll also learn something new about your problem. And that to me is very interesting as well, because I like having a human in a loop whenever I'm doing these sorts of things. That also helps prevent a whole lot of missing pedestrians. So, if you're interested in the demo, come find me after. I'll gladly show you in a bit. The main thing I want to give to you is like these tools are open source. I made these as experiments to sort of help Prodigy users see if we can help them with some new tricks. The main thing I do want to remind everyone, as cool as all of these things are, they are just tricks. If you want high quality data, you want to iterate with a team that cares. And that caring is maybe more important than having yet another pip installable package in your tool belt. Also, these tricks are only meant to help you get started. I can definitely imagine that if you already have your first 1,000 labels, then there are other techniques that are probably going to be helping you more than what I'm doing here. But still, we have these pre-trained models, so we might be able to use them to help ourselves label. Finally, there's also tons of other techniques that I didn't have time for. Submodule optimization is a really cool trick. Active learning, phrase embeddings, subword embeddings, keyword retrieval, neural search. There's tons of other stuff that I'm working on. But I do think bulk on its own is ready for use, and I would be interested in getting feedback. So if you have any, do mention it online. I actually get some time to work on this. Yeah, that's actually also something you do. If you actually want to see the demo that I couldn't do here, go to YouTube, because part of my work is also to make demonstrations of this. And also, if you're interested in tutorials and like tricks to find bad labels, like labeling tricks, I try to document that for Prodigy users. The videos are designed in such a way that even if you don't like to use Prodigy, you can still learn something from it. So if this sounds interesting, definitely check out our YouTube channel, because it's part of my job to populate this. Great. Final plug, the company I work for makes a tool called Spacey, and very recently we've started also doing some consultancy on the side. This is great because it helps us be a company that doesn't just make the tool, we also actually use it for clients. I can also confirm that it has already caused a couple of new features to appear in the library, and if that sounds interesting to you, please come talk to me. We also have a new service that was announced 2 days ago called Tailored Analysis, where we help you with annotation practices and consultancy around that. I hope this was interesting. Thanks for listening. I have a bunch of stickers if you're interested, by the way, so come find me for that as well. So also some rare exclusives from the Spacey team. And then as a final comment, if you know this website, also come talk to me after, because I have some questions for you. And again, it is such a cool demo. Like, come to the stage later. Like, it's such a cool demo. But I hope this is also educational.
I think it's time for some questions.
I guess so.
Does anyone have some questions for Vincent?
Or a data science joke.
Or some jokes.
Or a joke. That's also fine. Hi.
Great presentation, and
Thanks.
congratulations for the 3 blue, 1 brown
Oh,
award.
yeah, thanks.
Yeah,
Yeah, it was
well
a prize I
done.
won. Thank you. Yeah.
Have you tried to actually explore the embedded space with unsupervised techniques like variational autoencoders or
Oh, with unsupervised techniques, I think
Yeah.
TF-IDF and that sort of a thing.
more on the, because you are using pre-trained models, right?
Yeah.
But in a supervised way.
Yeah, okay, sure.
Variational autoencoders to generate like the embeddings and so on.
So the question was, right now I've mainly been talking about like embedding techniques, pre-trained models and such. And the question seems to be, well, can you maybe also do something with count vectors or TF-IDF or like unsupervised techniques based on top of your own data? You totally can, and it actually kind of works. The one thing to keep in mind is that, especially tricks like TF-IDF, you do end up with like very big sparse vectors. So the trick that I like to use is make the big sparse vector first, but then maybe pass it through SVD, because that's the algorithm in scikit-learn that can actually handle sparse input. It's like PCA, but for sparse stuff. And that works quite well if you've got longer documents too. Note that I'm saying this as an English speaker. It doesn't work as well for other languages, but for English and Dutch, it's actually quite reasonable to try that out. In general, though, the longer the sentence, like the moment you go towards like paragraphs or pages, this trick works less and less well. It's mainly meant for like 1 or 2 sentences. Or photos.
Thank you.
There are any other questions for Vincent?
Great talk, great talk. If you're going to branch off from Spacey and build your own classifiers, are you going to call it classy?
It's funny you mentioned that. So I actually maintain a couple of scikit-learn plugins. My token-based tricks are in a library called TokenWiser, which I thought was cute. But we also, Matthijs is around here, like there you go. He's a collaborator with me on a project called Scikit-Lego, which has Lego bricks for some scikit-learn pipelines. There's also some like rule-based systems that you can build using human learn. And I also PySquat a bunch of package names that are also going to be interesting. But that's I try not to have too many puns in the libraries because people do have to be able to find them. Like I have this one neural search library that I made the other day, like a year ago, and I've called it SimCity. It's impossible to find. Because I thought it was kind of cute, like, oh, similarity, build your own city, build a neighborhood. But then, like, no one can find it because SimCity is heavily indexed on, like, another thing online, so.
You realize you one-upped all the live demos of the world by doing live with GitHub page, right?
If you say so, thanks, yeah.
All right, thank you for your talk. Please make sure that you're gonna go see his demo. I think it's something.
And also, I have to go in an hour, so if you want to talk to me now,
so make
would be
it
the good
fast,
time.
People. All right, thanks again for your talk. A round of applause
Thank you.
for Vincent.